Good evening, fellow Plexers. I've been having a discussion with Daryl on the subject of software and hardware accelerated transcoding and why the default transcoding encode is H.264 and not something more modern like H.265, HEVC, or even AV1 or the future H.266. So, transcoding is a failsafe feature. No one wants to turn it on to purposely degrade a stream, but we absolutely love it as a failsafe feature because it makes sure that our video gets to where it's going, even if it has to degrade the quality of the stream, degrade the quality of the bitrate, degrade the quality of the resolution to make it to any particular client device, whether it's local or remote. So as a failsafe feature, Plex has to go with the lowest common denominator, which would be H.264. I have a buddy with a Roku Ultra LT. I don't know what the hell that device is, but it doesn't like lower bit rated HEVC 1080p media off my server. It buffers, and he thinks there's something wrong with my server. And my answer is junk that device and go get the cheap second gen ONN device if you can't spring for the second Fire Stick 4K Max or an NVIDIA Shield. So really, this lowest common denominator is older proprietary client apps on like a Samsung TV or an old Roku device that may only have a 2.4 gigahertz Wi-Fi chipset and doesn't have the capabilities to decode HEVC or H.265 media, which are the same thing. You can say either or. So here's a test server on a test unraid install. It is a i5 9500 9th gen CPU, and here's the older iGPU in it, which is quite capable. I've disabled hardware acceleration, so I'm going to show a 4K file encoded with AV1 without hardware acceleration, and then with hardware acceleration on this older device that does have some AV1 support in it, and then on my current server, which is an 11th gen mobile i5 processor with a fabulous Iris Xe graphics, all from the point of view of what the output's going to be. So first of all, let's get the dashboard, and this will be my reference file, but I want to show one typical HEVC file first and force that into a software transcode. This is one that I won't force to a hardware transcode. Alright, so you see the bit rate is only 3 megabits per second. It's direct playing, and it's a 1080p HEVC main 10, which means it's HDR. So let me force that into, well, I can't do the typical 4 megabit per second 720p, so I'll do the 720 2 megabit per second. So if we look, that's being reported, let me stop the stream, that's being reported as 480p, and you see it's being converted to an H.264 output to the client device, but it's retaining the HDR. I've got tone mapping turned on, but you're not going to notice any of that with this old black and white video. So let's go to our AV1 4K reference file off this older server. All right, so that's the one. So it started up direct play, and again we're going to force a it was in transcode. So we're forcing a software transcode to 480p. Let me bring that up to the more typical 720p. And if you look, our CPU usage is spiking. It looks like it was higher when it was forced to the 2 megabits per second, and a little bit lower when it was forced to the 4 megabit per second. And it's almost peaked at that one. But this is software, and that's what a software transcode is. It's very CPU intensive. So let's put this back into a direct stream. And you see our CPU usage plummets. So we're direct playing, and it doesn't take anything to do that. Let me get that back to the beginning. We'll come out of it, and now we will turn on hardware acceleration. That's off the iGPU. So let's get back to dashboard, and we'll start this up as the direct stream. So, I mean, that's easy peasy. And let's now force it to the, well, let's do both. Let's force it to the 2 megabit per second 720p transcode. Let's let it play for a second. So you see that is switched to the H.264 protocol again. It's a hardware, we know that. And look at our CPU usage. Now the 2 megabit per second 720p stream is using less resources than the software transcode. Let's see how it does at 4 megabits 720p. The app is keyboard driven, and I keep kind of forgetting what to do while I'm speaking. So it's about the same strain on the CPU. It's both of these are about 60%. It jumps around a little bit, but they're each better than a software transcode. The software transcode at the 4 megabit per second level was a little bit less resource intensive than the lower quality one, but it's still using a lot of CPU, which means that older 9th gen chip has limited AV1 support on its iGPU, but it does have support. All right, so let me get into my server. Luckily, no one's streaming anything tonight, which makes it easier because I don't have to worry about showing a friend's username. All right, so I want more. I want my server, and I want the 4K library, and I want this reference file. So hopefully nobody streams. Let's quickly turn off the iGPU. Most of my friends direct stream anyway, so this test probably won't really matter, even if somebody popped on the server. All right, let's take that back to the beginning. It's public domain, doesn't really matter, but we're direct playing. And let's force that 2 megabit per second transcode and check our CPU usage. Now, even though this is a CPU with a higher pass mark score, this is pretty easy. So let's switch to the 4 megabit per second 720 stream. And we see it's doing what it's supposed to do from this perspective. Now I guess it didn't want to show properly unless it was full screen. But we're getting a higher CPU usage. So the newer CPU is a little bit more powerful, but we're still putting strain on it with a software transcode. So let's back out of this, and we'll turn transcoding back on this 11th gen processor and see what we end up with this 4K AV1 file. We really don't have to show the original quality because a potato can serve this stream up. So let's go to the 2 megabit per second 720p. It starts right up. And now look at our CPU usage. It's minimal. Let's change this to 4 megabits per second. And I'm just bringing it back to the beginning to have less music coming out of it. So again, this is without the hardware, and this is with the hardware transcoding on the 11th gen processor. We have full AV1 support, and just this example would be exactly the same on a more inexpensive N100 Intel processor. It's like a new type of Celeron processor. It just would be great. Software transcodes, some people claim, are technically better quality, but the whole idea of a transcode is you degrade the quality to get it to the client device. So if you have a slightly tiny bit more degraded quality of a video at 720p than the 720p degraded quality from the H.264 encode, you're splitting hairs because it's still degraded from the original 4K quality of the media. So maybe if everything was HEVC encoded for the transcode, it'd be a tiny bit better picture after it's already degraded. But that's kind of like a weird thing to kind of shoot for. You want to watch the media in its original quality, and if you have to transcode it to get it to where it's going, you have to accept the fact that it's a lower quality image, and to split hairs over maybe improving that quality a slightly bit by having everything be converted to HEVC, when that conversion will knock older client devices out of the box from being able to receive that stream, is kind of insane once you think about it. So I'm beating a dead horse, but you have to understand why Plex picked the H.264 protocol to use with their fail-safe transcoding feature. Nobody wants a transcoded stream if they can have an original direct stream. Nobody wants the transcoded stream. That's what you have to think. Nobody wants that, but we're lucky to have it when we need it. So hopefully this all makes sense. Hopefully you understand transcoding better, and hopefully you understand that even the fastest, most powerful CPU you can find, your CPU usage is going to pop up with the software transcode. With all the money you save by just buying what is now an older i5 processor, a run-of-the-mill i5 processor with an iGPU, your CPU usage is negligible. You're not taxing the server at all with that hardware transcode. You're going to tax every CPU with a software transcode. And again, if you don't have to transcode, you're watching your beautiful original quality media without any stress of the server. Direct streams don't raise the CPU usage at all, which is why they say a potato can serve up direct streams. It's why people can successfully use a Raspberry Pi at home with compatible client devices. When someone mentions a pass mark score as being needed to play media, they've read a single Plex support article and haven't read the other articles about hardware accelerated streams. It really is this simple, and all of this can be checked out for yourself. I dare anyone to show me a Plex stream that once it's transcoded, it's not in the H.264 format. This is Plex's failsafe feature, and that's all you're going to see. And until even the cheapest Roku can successfully play H.265 or HEVC, or there's no longer a Samsung TV with a proprietary Plex app that can't play H.265, you're not going to see this change, and there's no reason for it to really change. What will change this is when Plex doesn't have to pay a royalty for either H.264 or H.265, which is HEVC. When we get far enough down the road where AV1 can be used without any royalties paid, and every single client device can support the AV1 protocol, that's when Plex might change things, because they'll save money and they'll have no reason not to do it. So, hope that makes sense, and I wish I had talked about this in my earlier video. Thanks for watching, and happy Plexing.